Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concept of projections. So as per part A, for the vectors P and Q, determine the scalar and vector projections of P on Q. So let's start with part A. So we'll start with the scalar projection and the formula is. So this is the formula for scalar projection of vector P on vector Q. So we can use the given vectors. For the magnitude of Q, we should square the components of vector Q, add them and apply square root to the sum. Now we can multiply the x, y and z components for the dot product in the numerator. Now we can multiply the numbers in the numerator. And in the denominator, 16 plus 25 plus 400 is equal to 441 and square root of 441 is equal to 21. Now we can add the numbers in the numerator. So I got 458 over 21. So this is the scalar projection of vector P on vector Q. Now we can find the vector projection. And the formula is P dot Q over square of magnitude of vector Q times vector Q. So we calculated the dot product of P and Q for scalar projection and we got 458 and the magnitude of vector Q is 21 and vector Q is 21 square is equal to 441. So this is the vector projection for vector P on Q. So we can leave the answer in this scalar multiplication format because if we distribute 458 over 441 in vector Q, we'll get long decimal numbers. So this can be the final answer for vector projection. So we are done with part A. Now we can analyze part B. Direction angles are angles a vector makes with the coordinate axes. Now, vector P is a 3D vector, so the direction angles are the angles it makes with x, y and z axes. So for that we have to use the formula for direction cosines. So let's assume the vector P makes an angle x with the x-axis. So the formula for direction cosine for angle with x-axis is, so in this formula, A, B, and C are the components of vector P. So we have A in the numerator because we are finding the angle of vector P with the x-axis. Now we can sub in the values. So for vector P, A is 3, B is 6, and C is negative 22. Now we can simplify the expression in the denominator. So 3 square plus 6 square plus negative 22 square is equal to 529, and square root of 529 is equal to 23. Now we can do the inverse of cos. And I got 82.5 degrees. So that's the angle vector P makes with x-axis. Now we can find the angle it makes with y-axis, and for that we can use the direction cosine for angle y. So in this formula, y represents the angle vector P makes with y-axis, B is the y component of vector P. So in the denominator, we got 23 for angle x. Now we can do the inverse of cos. So I got 74.9 degrees. Now we can find the angle vector P makes with z-axis. So we are using C in the numerator because that's the z component for vector P. So the denominator is equal to 23. Now we can do the inverse of cos. So I got z equals 163 degrees. So this is the angle vector P makes with z-axis. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.